Hey everyone, this is just a quick video I'm going to throw together to show you a simulator I wrote for the Ford Smart Vehicle Connectivity Challenge. So this challenge is a hackathon basically using the FordConnect API, which has remote commands and remote data. So the simulator I wrote is up on GitHub. I'll put a link down below to FordConnect Sim. The simulator itself is going to be up until the hackathon judging date, and then I'm going to make the simulator private again. So it's only there public during the hack. So let's just kind of jump into it. Sorry, like I said, there's going to be lots of uhs and ums in this video. So when you load the simulator, there's a vehicles.js. And basically you say like there's internal combustion engines and electric vehicle engines. And so for internal combustions, we have this kind of information about your vehicle, make, model, that kind of stuff. This is for the simulator. And then also information about what's your fuel level initially, your battery charge, mileage, status around how the tires are doing and if the doors are open or closed. And this is a second vehicle. In this case, I don't have all that extra information because the modem's not enabled, and it turns out the vehicle is set to false, so it's not even compatible with the system, and it also hasn't been authorized by the user. So you're able to put these to true or false, make your scenarios. Here's an example electric vehicle. These vehicle IDs don't matter, so I'm just putting in big random numbers. And then here's an example of electric vehicle. It looks similar to the ICE vehicle. And then down in here, you'll notice that the fuel level value is null for electric vehicles, and the battery charge level is how charged up the electric vehicle battery is, and the D to E is for the electric vehicle versus the fuel. Those are in kilometers, not miles. If you look at the Ford SDK documentation, it does a pretty good job walking through most of what these parameters are. So that's basically how that works. In app.js, we have, let me switch up to the top here. We have here around line 100, this might move back and forth a little bit depending how it's factored, but here's where we make those vehicles. So there's a vehicle list and we're pushing in the ICE vehicle and the second vehicle and the final EV vehicle. And the EV vehicle has this extra EV1 data as well, which I just kind of glossed over, but that has stuff like the departure times. And so basically the API gives you the next departure time, but you can have a list of departure times that the car would let you program. A normal EV lets you program 2 entries per day in the UI. And then charge schedules in the EV, you can basically add new locations in the real electric vehicle. It gives you a name, and then on a map you pick where it is, so the lat long. And then you pick the charge level, and then you can set up a weekend and a weekday charging times. And it looks like there's 2 of those in the UI that you can set for a weekend, and 2 you can set for a weekday. So that's that. And all this information is used to help power the simulator. So the README is also available. If you just go to the GitHub and you scroll down in the README, you can see it here. So it's just in Markdown. This is how you install it, and this is how you run it. So let's go ahead and run that now. Sorry, let's do this window. Cool. So now it's running, and it's listening on port 80. And if you already have another device listening on port 80, so let's say, you have I don't know, some other app, web server, then when you go to run it, you're going to get this error instead, which is the already in use port 80. In that case, what you're going to have to do is in supported environment variables, there's an HTTP port. And so you'll just go in and copy that variable and set it to a new number, 8080 or 8000 or whatever. And now when you run it, it'll be listening on that port instead. So that's kind of one of the troubleshooting steps you might need to do when you go to use this. There's some other environment variables as well that we had that come in pretty handy for setting timeouts and stuff. So right now it's defaulting to 20 minutes because that's what the real device defaults to. But if you want to test timeouts, then you might want to shrink it. And if you don't want to test timeouts, you want to make it longer. Likewise, when you issue commands, the commands you get back are good for 2 minutes. You could make those 3 minutes or however long you want. There's also some shortcuts for security. I don't recommend those, but if you find that helps make your life easier, then go for it. When we did pull up when we created those vehicles, there was a URL for the car, and that's these pictures. So you can add more pictures and set those as your thumbnails for the mock cars you create. Cool. So the endpoints are all the same endpoints as what Ford has provided us. So there's nothing really to talk about there. And then the simulator has a bunch of extra endpoints, which lets you change simulation data. And I think that's what we want to be looking at. So we're about 6 minutes in already. And the good news is we're 6 minutes in on a 20-minute token. So let's go over to Postman. Cool. So in Postman, what I've done is I've gone ahead and I've erased the domain of all these entries from Ford and just switched them with a variable called domain. And then I went in and I added, through edit, you can add the domain and put in localhost 8080. If you want to use ngrok, you can actually put an external internet URL as well. But for this case, let's just stick with localhost on 80. Cool. Hopefully you're following me so far. So the OAuth thing is slightly different than what Ford has. And so what you have to do is there's going to be some ID up here. It's probably not going to be that number, but it's going to be a number. And go ahead and delete that and hit save. And then here again, you're going to delete that and save. And hopefully this collection is your testing collection and not the one that you're going to use to actually talk to the real endpoint. Because, reasons. So, cool. So we're at Ford get token. We go to the body and we need the code. Normally, for the real device, what you would do is you would go and use the URL that Ford provided. You would log in and you would pick a vehicle, and that would then redirect you to localhost 3000 with a code equals some big long set of characters. In this case, the code's a lot smaller, but that's the one we use. And we're going to send that. And what just happened was we sent that to our simulator. And our simulator issued us an access token and a refresh token at this point. Now we can go and get refresh tokens. And our simulator now issued another set of access and refresh tokens. Refresh tokens are good for 90 days. You can use any of them. Access tokens are good for 20 minutes or however long you've set your environment variable. Cool. So now let's go ahead and get a list of vehicles. So these are those vehicles we saw. So here's an EV. So let's go ahead and edit our Ford Dev 3 and change our vehicle ID. Doesn't look like I have one in here. So I'm just going to make one real quick. Vehicle ID, and there it is. And save that. Let's hover over this to make sure it took it. Yep, it did. That's the current vehicle. So now we are going to go ahead and unlock So that sent a request to the simulator, and it asked to unlock the car, and we can see that it said it completed and the car is now unlocked. If we had done unlock and then came real fast and asked it, you'll see it's a pending response. So the simulator is simulating that sometimes these calls take a few seconds. So if you do post and then get real quick, you're going to get that middle state that you're going to have to retry on. So now we've sent an unlock. So let's jump down to vehicle information and go ahead and look at it. And so now we should see that, never mind, that's not where it is. It's in vehicle status, I believe. Send, get. Yeah, so the status is unlocked. So our car is unlocked. If we go ahead and lock it, even if we don't bother to look at the status, let's go ahead and send this, and then send this. Now you can see it's locked. So this was one of the new status refreshes, one of the new APIs. And the simulator, this is just the simulator pretending to be that API, and it gives you a lock status. So this works pretty much the way you would expect. You can also see the alarm here. I'm guessing it's set and not set, but I'm not positive on that. So in the simulator, these are not provided by Ford. This is provided by this project. It's a different route called /sim instead of v1. And on the sim route, we have an alarm, and let's just say enabled is X. You'll get back parameter enabled must be a true or a false. So let's go ahead and say true. Alarm set to true. So now we can refresh this, and command IDs are good for 2 minutes. So we can use the same ones again, and they'll usually refresh the data. They always do in the simulator, but in real FordConnect, I've also noticed that behavior. I'm not sure if that's just a coincidence on some APIs or what. So now you can see it's set. This may be a different word in the future, but this is kind of showing you an example of how you can now change the use the alarm thing. So here is our, let's request the location for our vehicle. So it is at this location right now, just sitting there. And we can go to set location if we want. And we can put in a new latitude and longitude and distance. We can also pass in an optional speed and a direction. And so now you can see that the latitude and longitude just moved. I think you can see it's a bug. This should be strings, so I'll fix that. Sorry about that. And we're almost at time, but hopefully that gives you an idea of how the simulator works. It has things like setting today, which would impact the EV departure times, because when you do a departure time on an EV, you only get the next time, which is Friday. So if you set today to be Saturday, for example, then the next EV that was set in our mock data is going to be returned, and that's the Tuesday one. So that's an example of the today. PSI warning is for the tire pressure, the modem, deep sleep, etc. And the README walks you through all the endpoints, and hopefully this video has been helpful. If I can help anymore, reach out to me in the Slack, and I'll see you then. Thanks.